Absolutely fine. No, Tom, not just as a person you have influenced me, because I've seen like a lot of people in the world of data science who have influenced people, but you're a different kind of an influence to me because
Hey,
no, because I've been seeing a lot of folks who have really been touching different people in the community. But Tom Ives is somebody different. So yeah, I want to do part two with you. And thanks for Manpreet Budhraja for coming to this podcast series of part two with you both. And it's an honor for me to have you both and trying to demystify a lot of things. So hopefully we demystify a lot. And if possible, let it be part infinity. I don't mind about it. So happy to see you, Tom.
Happy to see you. And I need you to understand something. Um, I know it's hard for some people to understand. Um, Even old PhDs can have fears and um, be afraid to, step out and do new and bigger things. You wouldn't be talking to me right now if it weren't for Manpreet. I really want people to know that because uh, she's, as we say in my part of the world, she's very much my right hand man. A lot of people think Geith is because we're co-authoring and we do a lot, but actually it's Manpreet. And even Geith knows that. He knows that. But um, Manpreet really is my daughter. She has to get my approval also. She has three parents, basically. So when she gets married, she's got to get her biological parents' approval and then my approval. And that guy better be good. So we'll see how it goes for that guy. He'll be lucky.
I know. Yeah, let's get it started. You both have a belief system. You both are bonded. You both have been made for each other. Just like a daughter, just like a father. I know that. I just want to talk about a little bit on the belief system. What's the big deal with the belief system that we can think about? Okay, let me just put it as machines which are making decision being more secure for a human being, or else are we just trying to put the human belief system into the world of machines in the form of bits? What's that all about? What is all about belief system in a short?
Now, are you asking how machines can begin to have a belief system?
Yes.
Okay, let's backtrack a little bit. And Manpreet, if you have something to add while I'm talking, raise your hand because I'm going to just lead off here for with some thoughts. Let's think back to before we had reinforced learning and Richard Sutton was a graduate student. Well, where did he come from? He came from the field of psychology. And yet, I would really like to, Dr. Sutton's still alive. I'm hoping I can meet him and ask him some questions. I'd be very curious to understand what motivated him to get into the world of artificial intelligence and data science. But we know at some point he started to find a way to ask questions. Posing a question is a very powerful thing when it's done well. I don't mean to imply that there's bad questions. That's not my point. Really break really big breakthroughs happen because questions were posed well. And he began to pose questions about how we learn. And obviously, it's a lot of trial and error. And Manpreet's going to be writing a post soon that summarizes a great talk she gave to our family recently on failure. It was great. It was just great. In fact, just so you know, Vishwas, the family talked about her talk 4 times longer than her talk was. It was hilarious in a good way. Um, and that ensued a pretty popular post that I just wrote last night. I was surprised how big a nerve it touched. But what I'm trying to say, Vishwas, and I don't think we've begun to ask the right questions to move machines toward general artificial intelligence? And I think that's what you're asking me. It
Yes,
to
yes.
me, to me, to move toward general artificial intelligence, or at least to appear to approach it, the machines need to say, and again, I'm not going to pose this well. I've been when I'm just laying around and thinking about the future of AI and how we might approach general AI, this makes my brain hurt. What how do you mathematically approach a machine that begins to ask its own questions? Now, I think for a machine just to be programmed to go and gather more data and learn from it, are we at the cusp of that? I don't know. Um, when we see what GPT-3 did, okay, it's encouraging, and yet there's still a boundary it hasn't broken. The encouraging part is much better than the three of us. It could go out there and collect massive amounts of data, and it can interpolate within that knowledge space. And so now it's in that envelope, but it can't extrapolate outside of that space. So given that space, I'm I have no doubt that GPT-3 or generations following it can learn to do a better and better job. And in fact, I'm not sure I've heard of it could be that Microsoft's already applied transfer learning to their copy of GPT-3. That would be phenomenal to see what it can do better based on that. But what has to be done for a system to extrapolate outside itself, to ask itself new questions? And so Sutton showed us, given an environment and overcoming the problems of the curse of dimensionality, now we can have a machine that doesn't have to have all the data to figure out good models, good policy to operate successfully. But again, how do you mathematically, and because by the way, all machine learning, all AI comes down to code and math. Let's remember that. What is the math of posing new questions, of becoming sentient? What is the math of becoming sentient? If you ask GPT-3, who are you? Well, it can only answer that if it's been programmed to answer that. If it has self-awareness, that doesn't really make it sentient. It also would have to ask something like, why am I here? Where am I going? When you see when you see artificial intelligence beginning to pose questions like that, and other sentient being type questions, that's when we've gotten there. But again, I've not seen anyone pose the right questions. Now, there could be some researchers in a lab somewhere who are working with philosophers and psychologists, and if they are, we don't know about it yet. But it really is posing the right questions so you can begin to apply an architecture that can mathematically deal with it. Now, the other thing is, it's hard enough for a large reinforced learning system to get somewhere. Just because you have all the resources and you have a bunch of really smart friends and you are truly integrating and synergizing on the efforts to make a new RL system train well, it doesn't mean it's going to train. Some of these RL systems, they work very hard to get them to a point where they will train and achieve the success they were aiming for. So it is not easy, even for the top people in the world. So given that, I think this next step toward general AI, and by the way, I would even say we need to pose a roadmap. if we're really interested to get to general AI, we might want to ask, why do we want to do that? What would that general AI do for us, or what would that army of general AIs do for us? And is there a roadmap to get there? Like maybe we should do 10 steps on the way, and but that takes a new level of thinking, and I'm not sure we have the level of thinking we need to be at to get there yet. However, I don't think our current hardware may be a limitation. It may be that we need to start thinking about how we would apply quantum to this. Now, to the challenging, hopefully constructively challenging person listening right now, they may be very upset with me thinking something like, well, why wouldn't quantum solve it? Or, what do you mean by that? And because, our brains aren't quantum level. No, our brains are something entirely different. And there's even arguments among the greatest intellects of history over what we really are. Are we spiritual? Are we just organic? But yet, even the human mind defies our own ability to understand it. Our own abilities. We are pattern recognition experts extraordinaire. And yes, we can get machines that do certain aspects of what we do better and faster, but there's always this additional realm that they can't match humans. And let's not lose sight of the fact that AIs require humans. I am a theist. I don't mind hiding that. I don't apologize for it. In fact, I'm very convinced in my own mind that God exists mathematically and chemically and cosmologically and everything. So I regard myself as having a creator, but AIs also have a creator. That machine intelligence relies on an organic intelligence to create it and feed it and supply it its energy it needs to run. I mean, think about it. Just like in my mind, the human race, relies on a God, and a benevolent one at that. And that might make some people angry. I'm sorry for that, because I've been on that side too. Really, if you think about a general AI, let's just assume it exists. How did it get there? It got there because of human ingenuity. It got there because we provided it the hardware to run. So these general AIs, what do they rely on us for? Well, we have to build and manufacture their hardware, be it current technology or the upcoming quantum technology, which already exists. At least we can already simulate running those. I don't know if at speed or not. When you get online to run quantum code, I actually don't know if that's a real quantum computer or simulator yet. But for that to become more wide scale, for it to become miniaturized, there's so many more steps, and it may not need to become miniaturized. It may be able to start out just fine at the larger scale, but to begin to devote the development and growth of a general AI on a quantum system. So in summary, if AIs or any type of intelligent machines that we create, or even if we reach someday, which I tend to agree with Dennis Rothman, I don't currently believe we will get there, but I would not criticize people that were trying to get us there. I would just ask them, why are you trying to get us there? Is it just because you think it's cool, or do you see a real purpose, a value to humanity in doing that? But let's say we get there and they're sentient and they have their own will, which would be kind of impossible unless they learn to make themselves like we see in some movies. By the way, I think Hollywood drives more belief in the public about fear of AI than reality should. And But my biggest fear is the people that are capable of making super advanced AI systems, will they be good people or will they be evil people? Will they be people that care about their fellow humans or are just trying to get more than than other humans? That's what causes me concern, because we've seen this throughout history, Vishwas. When something new and powerful comes along, it's not that it's a problem, it's the humans that use it that cause the problem. The humans that have that power, and when they misuse that power, that's what causes the problems. Now, I've been talking quite a while. I'd like to hear if Manpreet has anything to add. No? Okay.
Yeah, I think you answered a lot on the philosophy of having a belief system and then machine. How secure can we build tomorrow, or else what's the reason behind building such a humongous intelligence on a machine? That's true, but like, what's the unreasonable and unpredictable mystery behind ruling a rule on a math, a rule based approach and all the things which we are talking about in the AI and the field? What's the unreasonable effective of mathematics in getting these machines the same intelligence that we are desiring for? you know you can refer to any of the theories that you have come across which are more likely to be a myth, but one day it's going to be a fact, or a kind of an mathematics where you have seen that it has worked in some field but predicted that it wouldn't have it work, because we have seen a lot and lot of algorithms which were supposed to work on space algorithms work pretty well on the medical images. So anything like that.
Yeah. Can I go? Or you wanna
Yes,
go
Yeah.
ahead?
yes.
Well, me being myself from the maths background, initially in school we study just a simple thing, two variables, and then when we grow up, we have this Euclidean space, and that's all imaginable. That is our n space. In n dimensions, we have this vector space. Taking a very small example from encoding. Uh, a sentence you encode into vectors, one hot encoding. Ram is a good boy. And when you encode it into a vector, you create a vocabulary of vectors 1000, 0100, 0010, 0001. And that's your vocabulary based what you can say vector dimension is based on your vocabulary, and that's how you relate maths. I feel numbers had been always there when you code maths, because since school we had studied that when you code, you convert it into binary, and that's what a computer understands. Number had been always there, but it's just that now it's being realized how important maths is. And I still feel that I studied maths in so depth because I was from applied maths. I'd studied subjects like topology and space dimensions, which
Graph
I
theory.
think, yeah, graph theory is somewhat getting used in the graph networks, and knowledge graphs is nothing less than having nodes and elements to it is graph theory. So I think everything is maths that comes, and if you love maths, you love data science. I'm not saying that being a person data analyst or into data governance, data science consultancy, you need maths. If you're selling your product to clients and telling them you can leverage AI services, you need to know maths of the sales, of the finance, to calculate profits. I guess maths has been everywhere ever since, but we are realizing it now, the importance of it.
Yeah, abacus was the Napier bones were there, all dealt with numbers.
Um, in during our childhood, my mother put me up in this thing called Aloha, where we had this imaginary package. So you go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and that's how you mentally start to calculate. Shakuntala Devi is one of the biggest example of mathematician. How do you forget Ramanujan? a guy who found out a number from a taxi 1729, which is exactly like a cube of two numbers summing up, is
2.4.
Raman.
12 cube plus the 1 cube, 10 cube plus the 9 cube. Yeah, I
Yeah.
know it's an.
So if you enjoy your subject, irrespective you are doing arts, you are doing science, you are doing whatever you're doing, even you're blogging, you are a content creator on YouTube, if you enjoy your profession, if you actually love it, you actually enjoy doing it. I feel people nowadays rush into data science because they feel it's the hype, but with time they get depressed because no jobs. Actually, there are jobs, but they need people who actually understand the algorithms, the vector space, and stuff. But that's very thing that people don't actually talk in colleges. The courses they give, they don't actually talk of the real picture because they think that their course would not sell, people would not like it. But I think it's important to tell them a reality rather than getting depressed after their colleges and not getting jobs.
Actually, Vishwas, Manpreet and I wrote a blog post with Abdul Ajib that we just think is really important to the community. Um, I'd like to just highlight myself very briefly regarding that post. Um, I was doing predictive analytics with physics for the most part in graduate school, and I learned about neural networks in graduate school and expert systems, took courses in them, audited some courses, even got to where I was helping some students with some neural network design. But I completed my graduate work not even at the time realizing that part of my modeling for my dissertation had included some artificial intelligence aspects in it. And then as I entered industry, I tried to employ my advanced predictive modeling skills every chance I got, but I noticed over time it had switched from physics based to data based. And so when it's data based, I just thought of calling that empirical. But then I became more aware that, oh, this field of using pure data to predict things is exploding. And so then I found that, wow, even if I try to start keeping up with this, I can't keep up with all of it. And, but eventually, just because I knew how to explain things from a data science perspective in my interview, I got a role as a data scientist. And, but the point I'm trying to make, and the point the article makes, and I think Manpreet lives this very well, is that it's not about getting a data science role. It's not about getting a data science title. There's too much of a fixation on that. It's about getting the best role you can get and applying data to help you do better in that role. And let's point out this. A lot of that is not necessarily predictive modeling. It can be just good data visualization. It can be good data automation. There's a lot of things that need to be done with data that aren't predictive modeling. And you want to do good at those tasks so that you can produce good models and models that are updated over time too. So the summary of this is to say, always be a data scientist. Well, what does a good data scientist do? They do data science. Now, after you've done that for a while, you will eventually have the recognition as being as a data scientist. The current company you're at may change your title. You might get a role finally that says data science in it. But to hold back your career, your earning, your sustenance because you didn't get a data science job title, that's not a good perspective. And I know Manpreet's very appreciative of her data engineering role with her company because she realizes, oh, this is such a good start for my data science career. But Manpreet studies NLP in her free time. She's continuing to grow her knowledge. That's why she could talk the way she was talking about the math. And she's growing her coding skills too, which is hugely important in her role. By the way, for those listening out there, what's the best thing you can always work on to become a better data scientist? Get better at your coding in your primary language. You know, I prefer Python. I have friends that prefer R. They're both good. There's reasons I prefer Python, but the point is just make sure you have a primary language that you're comfortable coding in, and you know how to apply the basics of data science inside of it.
That covers all. There's a huge demand for mathematics. Of course, data scientist has to remain data scientist for a while, not for a while throughout his journey, but you know, people have not really understood the way in which the math really works, the reality of application of the mathematics in their research, or else in their problem statement at all. You know, when we talk about NLP is a whole new approach apart from your deep learning and the computer vision models, because will not be effectively dealing with pixels as numbers, but we'll be trying to put in the labels and we'll be just trying to fiddle out our way through the neural network. But like, what's the underlying myth behind understanding and explaining the math for making a person understand that this is the reality of the application of mathematics in this domain or this research problem statement?
This is a really important question. Um, I remember when I was an undergrad being completely mystified by dynamic systems. But then fast forward, I remember when I finally got it, and I had to look back, Vishwas, and think, how am I going to avoid that deep fog I felt like I was going through initially? And it occurred to me that, oh, I don't think the fog will ever be as deep again. Why? Because I don't want to say I've mastered the skill. I just want to say I'm passionate about the skill, and it's this: master the concepts of the math. Don't worry so much about the detailed equations, because you're going to have to review that. I mean, you were talking about Dennis Rothman earlier when we weren't recording, and how he is constantly reviewing detailed math things. Dennis and I have a friend that we both deeply admire, Marcin Beards, and we just consider this guy a total mathematical brainiac, and we love to talk to him. But what does it come down to at the end of the day? Mastering the concepts. Even when you come across a new uh, type of math for maybe a control system or for reinforced learning or fuzzy logic or whatever, sometimes it can be hard as you're studying the math to just see the concepts. But once you see the basic concepts, it's quite demystified. So for anyone listening, I would say, yes, you want to eventually understand the detailed math, but understand the type of numerical situation it would apply to. And let's remember, the only reason we have math is, well, yes, to quantify things, to describe things. It's a way to describe things quantitatively. And if we remember that and we see how this particular area of math we're looking at accomplishes that, and how it can accomplish that in multiple realms. You mentioned when we were just talking personally about differential equations. And in my research, I've dealt with massive amounts of differential equations on a large system scale. There's a question of how do you organize that and how do you do it in a multi-physics realm? But at the end of the day, Vishwas, it just comes down to understanding, oh, you know, that differential equation is really just dealing with how this factor or feature changes with respect to this factor or feature. And once you start to understand, too, how to derive constitutive relations, sorry, that's a big word. It just means something like, say, how would you derive the equation for the force of a spring or the force due to accelerating a mass? Or And once you see the big picture of how you're using the math and the calculus to do that, and how the calculus was originally derived, it's never as big a deal anymore. That first time I was able to see, oh, I've got this. Now I can come up with these differential equations, but how do I put them into the computer when I don't have a high level package? Oh, it's simply this. Okay. And that takes steps, but there's always a piece of knowledge out there that can help you master that concept. And so you will forget the details. It's just human. I guarantee you will. But if you master the concepts, they'll take you far. Now that was longer than I meant to talk. I'm eager to hear what Manpreet has to say.
Yeah. So I was just saying, as Vishwas asked, how do you explain it to people? I think if you remember in our playgroup, we were taught ABCD by showing us pictures and visualizations, and that's how it got imprinted in our mind. I think the best way is to try teaching by visualizations, because nowadays everything is digitalized and people prefer watching. If they see an interesting image, they would definitely go rather than reading this whole text. Personally, I prefer that, to be very honest. Like, an interesting image just catches your mind more rather than just a long, very long text. Secondly, always try to think that initially you want him to know what the concept is, so you're teaching your parents. Your parents are not from the age of tech. So if you want to explain them, it could be in a way that they understand what is the tech. Even if they're very professional or just growing in this, a basic concept also helps. Okay, what does back propagation does? From this layer differentiate with respect to this, with respect to this. And once they know how things happening, deep knowledge is very important for you, because um, when you interview for big companies, they grill you on this. Many people don't agree, but they definitely grill you on this. Why this? Why this layer? Why this? Why this embedding space? Why not? Even when you go for your PhD interviews as well, they'll ask you, what is embedding space? Why n space? What does the vector space means? What does the n dimensional means? Small things matter. Be very good at your basics, and once you're doing a research or even doing a project, try to make good visualizations. It's not just a data analyst job to do a visualization, because when you're building your model or project and someday you have to tell your recruiter you did, he won't go and see your code. Why would he see your code? What he'll get? A small visualization would tell him, you approach this problem, use algorithms, you got this, and that's done, and that's how you win.
I completely agree with what Manpreet was just saying. What I'm finding the older I get is, oh, I could have made my life and my learning so much easier by more visualization. Even when I'm coding something new from scratch, even when there's not an existing library to help me with my current problem and I have to create something kind of new, I'm relying on existing concepts. But if I don't do frequent checks of the output of my code as I grow it piece by piece, if I don't visualize what's happening, I'm just making my work harder for myself. So, how can we translate this to our personal growth? If we don't try to better visualize what we're learning along the way, we're just going to make it harder for ourselves and slow ourselves down. But Vishwash, it takes extra energy to create those visualizations for yourself. You may think, oh, this is just for me, so I'll be sloppy about it. No, don't do that. Put a lot of energy into doing good visualization for yourself.
Yeah. Jay Almar. If you see his NLP concepts, he explains through visualizations. Awesome. I personally like it. I don't know people, but I like it.
Yeah, that's true. That's true, because we are supposed to learn through the ease. We are supposed to make our learning process an happiest moment of our life. We forget that and we go behind the complexity, and we go behind the rules which has been framed by the education system. Speaking of this education system, you know, I saw the commercial of Dennis Rothman, which Thom Ives did. It was amazing. He slept the whole time and waited for the FedEx, but it didn't arrive. Yep, I get that. But like, I saw, for the first time, I saw Thom Ives' computer set, which was being set like monitors up, the mic, everything. There's a Slack channel running in one monitor. There's something going on. He's trying to teach some mentees up. I just want to ask you this one question. What do you feel about the deep learning systems that we are trying to build in the future? I know Dennis Rothman has a good compute setup, which is being done, but like, I just want him to give a brief insight on what's the future compute aspect that we are looking for, basically breakthrough in the computing world.
Well, the nice thing is my company is very good to me. By the way, that 5-screen system that people saw in the commercial, it's one of the screens is just the laptop. The other 3 are just that they're nothing fancy. And the 5th one is to a separate Linux box that I just have to have a Linux box. There's just no way around it. And even if it's just a virtual machine. But more to your point, that I have a cloud server that I do a lot of my work in. And it's very important because my data engineer that I work with, not mine, I mean, my buddy data engineer that I work with, he supports that cloud server with stuff he does. My database engineer, and then all the people that support that database. So I get a copy of that database on my cloud server that I can update anytime. My system admin is running that. So now that's in a company environment where they're really trying to give me the systems I need to accomplish my work. But Vishwas, you can go rent cloud services. You could say, okay, here's my yearly hardware budget. And you might decide, okay, based on that budget, does it make more sense for me to go buy my own hardware or rent a cloud server and just have, a cheap, by the way, my monitors are cheap or loaned from the company. So they're nothing fancy, but, and frankly, my favorite monitor, even for the money, is a 43-inch 4K TV just sitting right here. And if it could be curved, it's better. But for our type of work, we don't need gaming speed. So you just need one that'll work good with a computer. That was the favorite monitor I ever had. But you could have like even a Chromebook and you're accessing a cloud server. And you don't want the Chromebook keyboard, in my opinion. You want a good full keyboard and mouse, but now you're just accessing your cloud server whenever you need to get to it. Now, for some people in parts of the world, they may be thinking my internet connection is not that reliable. It's not that fast. The reliable part I get, but you don't actually need a super fast internet connection to work reliably with a cloud server. And we're still getting into this. Now, I'm an old guy, so it's hard to break habits. I have a shop out that way on my property, and I have a big rack, and I have a lot of servers. They're just old servers I've collected that I like to play with. But if someone came along and said, Thom, that's silly. Why don't you just rent cloud servers? I'd go, guilty, just because I'm set in my ways and I like to play with the hardware. But I think I've gone on too long answering this. The point is, the hardest thing at this point is if you did want your own hardware and you didn't want to use a cloud server, then most of the time you can get by even without a fast GPU. Those rare times you need a GPU, as long as you have a Thunderbolt port, you can run an external GPU so that you can get that GPU speed. Now, if you're thinking, I really want to get the best training hardware I can for the lowest cost, you want a mining rig. But here's the advantage. You don't have to get the latest GPUs. Buy the cheaper previous generation GPUs and build up that mining rig and build up your ML training system that way. Because it can be expensive if you try to add a bunch of GPUs on a cloud server, but you don't need those all the time. You can have different system configurations and check out different things. So what I'm trying to say is, if you look at our on integrated machine learning and AI blog, we have a post about your personalized learning plan. You can have a personalized hardware plan too. You may not get there all at once, but just try to be honest with yourself. Okay, am I just a hardware junkie like Thom Ives, or will a cloud server that I can a routine where I can configure that cloud server fast, do my work, and get back off it. Now I don't need those GPUs. Now I can even run the model without a GPU. We don't. Once we're running a model, we don't need the GPUs. Now, one last thing. I love Colab, Google Colab. You can check out a GPU. Most of the time you can, well, okay. There may be different experiences, but Manpreet, you'll have to come off mute. I've talked long enough. Let's hear your experience.
No, collab is good. I think Avery Smith made a post on tell me one thing that you hate or like about collab. I think it's good, but when you're training, it after 12 hours of training, it gets shut off. That was my experience, and sometimes when you have a very heavy thing, the RAM gets completely full and then it gets shut down. So what interesting thing I found is if you have a good ramp of GB in your computer, you could integrate your local with your collab. It would run on your local RAM, but you could still use the GPU from collab. So it was very good thing.
Yeah.
But I prefer Jupyter Labs more now because they are much better with the UI.
Manpreet, I'd love to see you write a LinkedIn post or a blog post on that, so more people, because I wasn't aware of what you just said. The few times I've incorporated a GPU um, on Colab, I didn't need to train for like 12 hours. So that's good to know. I've heard other people complain about Colab and how they would prefer to use their own
Yeah, the
GPU.
ramp issue is the one thing. So when you integrate it to your local, it keeps running, so it doesn't get shut down so easily as it does in your collab thing. That's learned when I was doing my master thesis work. It was like so huge. Like texting is quite huge to pre-process, so it takes a lot of things.
Yeah, no, speaking of collab, everything is fine, but not all the models get deployed. Not all the models get
Also,
served.
one thing: all models don't need ML. Few things just needs regex, simple pandas, and numpy. It gets solved. In
That
real world,
is,
you don't need actually ML so much until you're actually building a ML centric application.
this is a very good point. I don't think it's said often enough in real world work. If you just look at the task at hand,
Yeah, I
it
have
it
never used till now.
I've used it a little bit, but a lot of times, at least in the work I've done, yes, I can train models. I can do deep learning. I can even derive neural networks from scratch and teach you how to do it. And it's kind of fun. It just takes a long time because it's like a big accounting work to get it all done. And it solves some fun problems. But when you just get into industry or you're serving human needs, a ton can be done from good data processing and visualization. And then a lot can be done with very basic approaches. Like I did create a very fast document matching machine for my company, but I didn't even embed the vectors. I just left them as occurrence rate vectors. Why? Because then I could use sparse matrices and I could grow it really fast like I needed to. So I just decided to bypass the current state of the art, is what I'm saying. And yes, it was a machine, but I just cheated basically. I said, no, I'm not going to do something like Word to Vec. I'm not going to embed the vectors because then I have to stop and retrain this giant corpus every time I do that. Why don't I just let it say? But Vishwas, here's the important thing. I got to that because I knew the concepts, and I still had to play with making it play well with SQL and not run out of memory and all of these things. But a lot of it was understanding coding and SQL Server and SQL and getting in. I'm still using ML type libraries in Python like scikit-learn and the sparse matrix routines. But if someone would come up and look at it, they'd go, "Oh, that's a really good cheat." You know, it's not your classical the way you're taught to do what I did. It
Yeah.
did.
It's also like sometimes hard, like if your company is not like FANG, like Facebook, Amazon, where you don't get so much of data, it's like really unnecessary you are using your company's resources, because it's a very good practice if you do something manually or create a process to categorize things and get your data collected correctly for like 1 year or 2 years, and then make a ML model. Now that you have enough data, you know it's correct because you did it. So now making an ML thing and automating is a good choice. But just with 5,000 data, you think that you. I feel this is a very wrong perspective that people have, and also in real world we don't get CSVs to deal with. We have a database we need to connect, and it's very important for people to learn SQL. Very important,
Yes.
irrespective of which role you are in. You, even in Power BI we also use SQL databases. You can't use millions of rows as a CSV file. So yeah, it's very important to learn SQL.
I would agree with that. There are rare exceptions. I'll explain. For decades, I was using just good file management systems in engineering companies I was at. We didn't need to use SQL for those cases. Just it was only because of the types of data we had and the way we were storing it. But then I came to a point where I was working with data where, okay, yeah, I know SQL, but I haven't used it a lot, and you know what that can cause. So luckily, there were uh, because of understanding the concepts. By the way, I'd been working with pandas a lot. So if you've been working with pandas a lot, even if you haven't been working with SQL, you've been thinking in SQL concepts because of pandas. So that's nice. And pandas is super fast and powerful, just like SQL. But I echo what Manpreet's saying, but there are some data scientists out there engineers who are doing mostly data science work, and they're in areas where they don't necessarily use SQL a lot, and then now they have to learn SQL, but it's not too hard. SQL is a very elegant, easy to understand language, but there's a learning curve to it, and I had to incur that in the not too distant past. But luckily, there's always someone around to help you. And the most important thing, if you're new to SQL and you're in a job and you're facing some very difficult queries, query designer. Almost all of you can find one anywhere, but if a lot of people out there are probably using SQL Server, and get good with the query designer, because sometimes it'll just save you a lot of time coming up with those more complicated queries. That's all I wanted to add, but Manpreet's right on.
Yeah.
Yeah. Also, pandas I think is sometimes very underhyped.
I agree
People
with
don't
that. I
value.
agree with that.
I learned most of the things Jason normalized. I never knew you could do. I learned at work. Pivot table, clearing things, dropping things, duplicates was so important. And I think it's so underrated at times.
Yeah, even Eland is there from the Elastic Co. Making huge amount of scalability issues solved when it comes to pandas. When we are doing more amount of batch processing. I work in a firm. Basically we do a lot of stream processing. We don't work on batch process data because we don't generally store data and process it. We always try to do the real time analysis. So yeah, kind of, speaking of all these, underhyped and overhyped, and the hope of the frameworks, I just want to ask you this one question. Every coming out, every company is coming out with the standard of Turing test. Google AI passed the Turing test. There are companies which are coming out with these benchmarks. What's the big deal when we consider human intelligence and the Alan Turing's test, which we are putting it as a benchmark for the intelligence of the system? What's it all about?
Well, I think it's a good thing. There's also glue and super glue and blue. When you get in the NLP realm, we
It's
just need
blue. It's glue also, and blue for translation task.
Yeah,
exactly. And I think it's a good thing we have these because it just helps us keep track of how well one deep learning architecture is doing with respect to another. Um, I think it's very important to have those because that now they're standardized. Um, and if someone wants to create a new metric system, they should and explain why they're creating it. Um, when GPT-3 is competing on one of these systems and you don't see it come out on top, it's important to understand why didn't it come out on top? Well, it's because it's doing zero shot. It didn't receive any additional training. And for the what it produced without that additional training was phenomenal. But and by the way, if you want to learn transformers, I do encourage people to buy Dennis's book on transformers, Dennis Rothman's book. Oh, here. Sorry for the delay. I just realized, oh, let's see. Oh, no. I have to go off there we go. That'll work. And it's really great because if you're trying to get started, it can be mystifying learning transformers. They're, I would say they're simple to learn. They're just not easy. There's just a lot of simple parts. And when you're learning it, you could probably torture one of your best friends, with questions while you're learning it. Manpreet's laughing because she was ahead of me in understanding transformers. And one day I called her and I was all upset about one of Jay Alamar's videos and Dennis's drawings. I said, but this and this and this. And I caused her to doubt herself the rest of the day until I messaged her back and said, oh, no, I was wrong.
But I would like to add, if people just starting, I think they should get the feel of Jensen models, sklearn, LSTMs. Why did they fail? RNN, because everything is based on something that failed, and that failure taught them something. That's why something state of art models you have. And the best thing now I see is you have domain adaptation models, BioBird. So good. Now that for medical you have your BioBird, you can just train it and you can create these domain adapted models. It's such a good helping thing for community, because when I was reading this COVID papers in ACL, you would see that most of them had used BioBird or something like that to train their models and build things. And most of the work was also a lot of manual work. And while doing things, you need to do a lot of manual work. Nothing is automated when you get your real world data. And secondly, I would like to add is, when you talk about these company publishing state of art things, you need to realize they have the highest computation power, highest data set, and things that would never work in real life, at least for a common man. If you are a
yeah.
person, because there are special issues that come for reviews of these papers. Why do they fail in real world? How do they fail?
No, yeah.
Yeah.
Recently, I actually did a podcast with Professor Peter Holland. He he's an person who is working in regenerative medicine for quite a while now. His his guide who guided him for the PhD was a Nobel laureate, and he literally said it didn't matter because what's the review that you might have it given might be underestimated by the other two reviewers. So other two reviewers will come in hand. So they have to publish somehow the paper, because those two reviewers have given a proper review for it. Things
Yeah.
happen wrong all sometimes,
There
right?
is also a lot of PR thing because these Transformers, Elmo, but I made a post. They're made on cartoon characters to make it a hype at
Yeah,
times, and I think it's quite justifiable because people could relate to it. Attention is all you need. It's such a good nowadays. If you see a pattern in papers, you would realize earlier they would name using RN and CNN made this. Now you would find, hey, how are you? It failed or something like that, not the actual thing they use. And that's for a reader to catch it to it. And nowadays, if you see, most of the authors are getting very active about their papers and things on Twitter to get it, more citations and read by people.
yeah,
Things are changing, but it's quite good that if you notice small things, there's a lot of things you can study in a paper as well. That's all I learned while doing the research work. So yeah.
I
yeah.
think a good way to summarize what we're trying to get at, Vishwas, it's great to understand these cutting edge tools because you're growing your mind, you're growing your conceptual knowledge, but most jobs don't require that level of implementation. Now, there may be cases where, yes, oh, I'm so glad I knew how to apply a neural network here. I'm so glad I knew how to apply a transformer here. But so often you can get work done with extremely basic tools. And let's not forget, if you do good feature engineering, good feature reduction, you treat your features with love, like you scale them, you clean them, you have cleaning and conditioning routines at the front of your pipeline. Once it's been scaled and you have routines to automatically retain the best features, find the best feature engineering. You can do so much with linear and logistic regression if you're very good at those things. And those models are self-explanatory. Because you scaled your features and you've encoded the text into numbers, now when you're looking at the model weights, they tell you a lot. They tell you what to go work on to make things better. And if you employ a deep learning system to solve a problem, now you don't necessarily have to backtrack to explain it, but wouldn't you want to know what features were most important? And now we have to employ explainable AI to the deep learning system so we can understand what features were most critical. And okay, that's great. We can do that. But if you could get the job done with linear or logistic regression or random forests, wouldn't you rather do that? Yes, you would rather do that. Now, for the reasons I described, I do prefer linear logistic regression over decision tree type systems, but their random forest and decision trees get a lot of work done out there when we do need ML. And you've seen probably a lot of comic posts on LinkedIn too, making fun of those people that run to deep learning. Of all the troll type, let's make fun of something posts, those are probably the most valuable to the community. I want to hear what Manpreet has to say.
Yeah, she
Uh,
conveyed it.
I no, I just want to say it's important to know the basic algorithms as well to go into your transformers thing. I don't think actually in real life use cases we use transformers so much unless and until it's like Alexa, Siri, and I don't know yet. Might be companies using building cancer detection things or something that of sort. And I love the way how computer vision community and NLP community coming together, building things, learning from each other. Quite good.
Yeah, it's true, because two communities are coming together. We are trying to solve the problems. Of course, hopefully everything gets solved through the AI and ML. That's what our bread and butter will be in the future. So, last question. I just wanted to just keep it short so that Not to make it a part 3 or something, but people don't tend to hear 2 hours or 3 hours of podcast. We can go ramble around, beat around the bush, and yeah, I just want to ask you this question of what's your best experience in doing research in this field of data science, deep learning, computer vision, NLP, anything. What's the best experience that you had, meeting people, that can be, or else reading a book, that can be any best experience that you had as a person who is researching in this field.
You wanna go? Okay. Research is not a cup of tea for everyone. First thing, you need a lot of patience. You need to go through a lot of papers. You need to understand what mindset that author was writing this paper, because it's very difficult to sometimes understand the terminology, and it's a very high possibility that you have to read a paper at least twice. And the best thing is you get to learn a lot. During my thesis, I was told to uh, told to explain that concept with the help of figure. Didn't want to understand, and that's when I realized, okay, I just read the paper. I made a summary of points and told them, but that they know already what is there in paper. Being a professor, they actually want me to understand with this diagram what the author wants to tell. What's the max behind it? Because someday when I have to recode that paper, I need to know the max so that I can recode that paper and implement it for something else. So I think patience to read a lot is one thing, and to give time to it is one thing. You have to give it a lot of time. Aiming a project in just 1 month in research is nothing. It takes months and years to print something. I guess Dennis wrote in a message in group that his whole office is filled with reading tons of research papers and books and different things to understand how do we write his own work, and that's such a good inspiration.
I just wanted to add, I loved what Manpreet was saying, but for me, there's so much I love about our technical space in general. Um, it, I think, oh boy, so much to say, but I'll try to be brief here. I think I always wanted to be part of a community that had what we now very well define in our family. What I mean is our integrated machine learning and AI family, where we have our Saturday morning mentoring sessions. And we really do, we're led by a spirit called more together. And we understand it. It doesn't take long to explain it to others. It's this: hey, are you better in some way than me? Great. Can you help me get as good as you? Sure. By the way, let me help you this other way too, and you can help me in this way. Let's help each other grow. Let's have more together. And we're a group of people. We don't want more than others. We don't want more knowledge than others. We don't want more money than others. We enjoy being a family. We want more together. And when you can learn that way, you learn faster, you learn better. You're not afraid of failure. You see failure as your friend, just just a gentle step in the learning process, and you're all laughing at it and encouraging one another. That's, to me, finding a community like that and realizing there were others that wanted to have that kind of spirit with each other. That's been the best thing ever in my whole career. And now that I see that there are others that are very smart too, like I try to call Dennis Rothman my big brother sometimes. Thom, we are equals. He's very, just like I am. I found he had to correct me like I correct the younger kids in our family. No, I'm not Dr. Ives here. I'm Thom. You know what? You're the future king. When you get my age, you're going to be more mature than me. You're going to be better at data science than me. You're going to be better at coding Python than me. I'm honored to help you get there too. But the world wasn't as technical when I was your age. So naturally, you're going to get ahead of me. In fact, I would even say the world wasn't as integrated and nice when I was your age. So you're going to get, you're going to be a better mentor than I am to you. And we've kind of proven too, mentoring from Thom, yeah, okay, that's okay. Thom cares about us. And so that's why it's good. But mentoring from the whole family, nothing comes close to that. So that's been the best thing in my career, is learning that way.
Thank you, Thom. It was amazing talking to you also. And thank you, Manpreet, for lending your time for the podcast with Thom. So, it's been something as an kind of a journey that I really wanted to be a part of. I don't mind if this podcast goes like hundreds or thousand parts. I don't care about it, because I just want Thom to be on my show. It's an honor to have you on my show, and thank you so much for giving your
But
time.
adding to this, we would also like you to have an on integrating mentoring sessions. I think
Yes.
we'll learn a lot.
Yes,
Yeah,
sure.
we'll add you to the group.
Yes, sure. I was actually waiting for this because thank you for that.